Hi kids, Mr. Sloan, just to talk about a couple things here in the greenhouse, practicalities based on what we've been talking about. Nutrients recycle. Plant nutrients, nitrogen, phosphorus, and potassium, some sort of form. Right now they're stored in these bags and bottles. Soon they'll be in the roots. That's one of the things. So, let's look at what we have. That's corn that was never transferred into a bigger pot or given more nutrients or more room to grow. Look at the color. It's used up all its nutrients. There's nothing left. I'm keeping it alive by water. Water is not a nutrient. I want you to look at this corn as a whole. See if you can see the color of the corn. Look at this corn as a whole. Here's one that didn't get nutrition right for some reason. Look at the pale color. Look at the leaves at the end. Compare that to this corn. Green, still growing even though it's been cold in the greenhouse. This one is even attempting to make an ear of corn. That's attempting to make an ear, poor little guy. In fact, they're all attempting to make ears right now. Not enough heat, but anyway, they're trying. So the nutrients now that were in that bag and sack are now here. Then they're stored here, along with carbon coming in, oxygen coming in, water from the roots, and now we're storing it at this point in the corn. Yeah, it's what, and you can see different, I mean, this side was fertilized, that side wasn't, and you can see various leaves. We just threw a bunch of them in pots that aren't doing very good, and of course they're too crowded too, so they're really competing for nutrients. This was just me throwing stuff in the greenhouse to try to make a video about nutrient cycling and energy flow. So, anyway, let's talk about what happens when these plants are done. Our corn came from the greenhouse. So, how do these nutrients cycle, or what can the energy be used for? Well, remember I mentioned on Friday, on our last day together, that we can combust chains of molecules and use them for energy stored in the bonds. Good. Not really. That's a corn tassel. But I can eat the corn. If I eat the corn, it's combustion. I use the energy. I use the heat. We have CO2. Here I put methane up here or something. Anyway, if I eat the corn, of course there's going to be waste from that too, but I can use the energy. Let's say we recycle all the corn. We recycle the nutrients. It goes in the compost. Now, let me just throw the whole thing. This whole thing's going in the compost. However, the bacteria, viruses, and protozoa will still eat the corn and decompose it. So they're still going to get energy. So there's still, when I put that into the compost, I am recycling nutrients, but I'm also feeding the microbes, and they're combusting. Okay, and the microbes then will give off carbon dioxide. They'll use the energy in the corn to live, and then what will be left, however, is some of the nutrients which will be put into here, such as the nitrogen, maybe some of the phosphorus, some of those compounds that the microbes didn't eat. So that's what happens. Since we're in the greenhouse, it gives us some great lessons about energy flow. The greenhouse itself, solar, sun. The energy comes down from the sun during the day. If it's sunny, it's not sunny today. Photosynthesis. Beautiful green plants that have been fertilized versus the ones that haven't, nutrients. They use the sun to make more leaf. They take carbon out of the air, and then they store it here to recycle. But the solar energy, gone forever. If it's a sunny day, it's 80 degrees in here. At night, though, it's not 80 because the energy dissipates. It's gone. And so it's gone. Once it's used, it's gone. But the energy is stored in the bonds for a short period of time until it's eaten by an animal or maybe turned into, buried deep under earth and not decomposed, and it turns into a hydrocarbon or gasoline. And we then use it later in the future to burn in our cars or boats. Which brings me to the next point. Look up at the furnace. So, we have to heat the greenhouse. The greenhouse is heated with combustion, stored materials. We use natural gas here for this greenhouse. We could use propane, we could use butane, we could use diesel oil. However, natural gas is clean, is very clean. It burns clean, only the products being carbon dioxide and water, so it burns really clean. There's a lot of heat in it, and it's very abundant, and it's piped right to the school, so we use it. However, once it's burned, it's gone. But that energy is gone. But those bonds that are broken, that ends up getting recycled, mostly CO2 into the atmosphere, and also water is left into the atmosphere. Did I put that in there? Yeah. In a complete, which we've talked about, which is on the movie, a complete decomposition reaction, hydrocarbon, oxygen equals heat with carbon dioxide and water. I'm not sure that equation is balanced, so it doesn't make any sense. Okay, so I think that's the essence of nutrient cycle and energy flows. Oh, let's do one more. Electricity, that's a fan. Electrical energy flows through the wires. This is energy that was probably at a dam, and it was stored in the dam. As it went down, it created turbines, and so it makes the wind. Once that wind is gone, then energy is gone. And there's a little heat in the motor. This motor is it's a really good motor, so there's not much heat in it. But once the air disperses, that's it. That energy is gone. We have to get more energy. And in this instance, there's no recycling of nutrients because this happened somewhere else, like at the coal plant or something. Now, and dams don't recycle any nutrients at all. They just have energy flowing. Okay, so I think those are the major points I wanted to make in the greenhouse about energy flow and nutrient cycling. Once again, though, but look at the corn. This corn without fertilizer, it did get good soil. Looks putrid. Look at that corn. Much better. Nitrogen, phosphorus, and potassium. Not to mention some pretty good lettuce. Not a lot of bonds, not a lot of energy, mostly water, but it's good.